The overall goal of this protocol is to understand the basic elements and steps required to accomplish an electrophoresis, which will allow the visualization and analysis of diverse nucleic acid samples in order to determine their ultimate quality. Agarose gel electrophoresis is widely used in diverse areas as it is a simple and precise analytical procedure. It is commonly prepared for research, biomedical and forensic laboratories. It is a powerful separation method used to analyze DNA fragments generated by restriction enzymes, as well as determining the size of DNA molecules from 500 to 30,000 base pairs. However, it can also separate other charged biomolecules such as dyes, RNA and proteins. It is important to mention that if RNA is to be analyzed, a previous denaturalization process is required to avoid the formation of secondary structures.
The centerpiece of this method is the horizontal gel electrophoresis apparatus. It is in essence a rectangular box with electrodes at each end that will provide conductivity and permanency. The separation medium is a gel made from agarose, that is a derivative from agar. It comes from seaweed and it's purified in order to remove impurities and charge. The powder is dissolved in boiling buffer solution and poured in a casting tray or mold. A well former template is placed across the end of the tray to form the wells when it solidifies. A fluorescent dye is used in order to observe the genetic material in an easier manner with the help of the transilluminator. There are different dyes that vary in sensitivity.
The running buffer serves as a conductor of electricity and to control pH for molecule stability. There are two used buffers, being TAE and TBE. The first is not recommended for lengthy processes, so the latter is used in large DNA fragment separation. The loading buffer is necessary to confer density to the samples, as well as color. The dyes used in loading buffer also migrate during the electrophoresis and help determine when the procedure should be stopped.
A power source will apply current, and the charged molecules enter the gels to the walls of the wheels. So, negative charged molecules migrate to the positive electrode for the anode and vice versa. It is important to apply the current voltage in function of the distance between the electrodes. The base pair marker is a mixture of DNAs of no size in which the sample can be compared once it has migrated. Depending on the expected size of the sample is the election of this marker.
First of all, it is necessary to choose the correct composition of the agarose gel that is to be prepared. For this, and taking into account that the gel chosen is at 2%, the appropriate calculations were made. 100 ml of TBE 0.5x are also needed, resulting then in the preparation of a gel of 100 ml total volume, with 5 ml of TBE taken from a 10x stock solution, 2 grams of agarose and 95 ml of distilled water. Beforehand, the electrophoresis chamber where the gel is to be set has been prepared with its comb. Calculations also in order to determine the amount of cybersafe that is to be added to the gel, which has to be dissolved in a microwave, taking precaution that it is not overheated. When it is boiling, the fluorescent dye is added at 0.3x concentration, taken from a 10,000x stock solution before the gel becomes viscous. Once it is poured into the chamber and left to set, the DNA samples are put on ice in order to be used later.
The TBE running buffer is poured onto the set gel previous to the sample loading, and this buffer of a 600 ml total volume contains 30 ml of TBE 0.5x and the rest is distilled water.
The order in which the samples are loaded is the base pair marker. PCR product, genomic DNA, plasmid, and the rest are filled with running buffer. 4 microliters of loading buffer were placed on a plastic surface in order to mix with the samples before placing in the wells, except for the first, which is the base pair marker, which already has loading buffer. By micropipetting, the samples are mixed with the loading buffer and then placed in the wells, carefully in order to ensure a correct electrophoresis.
The voltage used is 120 volts for 14 minutes, so as to visualize in the transilluminator and analyze the image obtained.
To visualize the results, the gel is removed from the chamber, getting rid of excess buffer and exposed to ultraviolet light in the gel documentation system.
First off, it is noticeable that in the 2% TBE agarose gel, there are dust particles in the gel, which occur when pouring it into the chamber to let it set. This is unfavorable and can be dealt with by not passing arms over the gel when it is being poured or after it is in the chamber. The base pair marker migrated well enough to distinguish the bands in order to know the size of the samples used, indicating that it was loaded correctly into the first well. The second well, that contained the PCR product, shows 2 bands, a more visible one at a 200 base pairs and a light one at a 400 base pairs. It cannot be said whether the size is expected but appears to be highly specific. The third well, corresponding to the genomic DNA, there is observable degradation of genetic material, as well as an excess of sample that is of the same or similar size, which explains the blackness that is observed on the lower part of the gel. The fourth well with the plasmic sample shows multiple undefined bands which correspond to the different conformations that can be found in plasmid material, being that it wasn't previously linearized. This does not mean that the size is variable, but refers to the form that the plasmid has in the moment that allows the migration with no regard to its base pairs. There is also protein contamination, as there is sample left in the well which can be avoided with phenol extraction.
The 1% agarose gel has similar patterns as the TBE agarose gel. However, the bands are better defined size-wise, being that the larger base pairs the band has, the more defined it is. This is due to the fact that this buffer is used in large nucleic acid separations, whereas the TBE buffer is more useful in smaller nucleic acid fragment separation. Furthermore, the voltage and time conditions set led to certain distortion in the TBE gel bands, differing from the alternate buffer because migration is quicker and more controlled.
As is known, the concentration of agarose affects the migration of genetic material, so if less concentration means the pores are bigger, then the migration is faster and the optimal size of fragments observed is larger than when using a more concentrated agarose gel. This is more noticeable taking the base pair marker as reference. It is important to take care of the gel when it is being prepared, as well as poured and left to set, so as not to contaminate it with dust or other particles that can later interfere with the visualization of good results. Moreover, it is crucial to prepare and load the sample correctly, so as to ensure a good electrophoresis and quality band fragments.
The most important aspect when realizing an electrophoresis include the hair composition, the running buffer, the selection of the base pair marker, the condition in which the procedure will be completed, being the adequate voltage and time, the visualization of DNA loaded, and of course, quality of the sample.